Okay, so we're on to page 7 of the running test review. The majority of your tests will come from problems like these, but will probably be slightly more complicated, more like the ones we've done most recently. So this is going back to how to graph linear equations, given a whole bunch of different information. So this one gives you a point and a slope. So the most common way to graph a linear equation is to plot a point or plot a y-intercept and then use rise over run to find a second point. So this point that we have right here is the first point we're going to graph. So that's over 1 and up 2. So we put a point right there. And now our slope of 2/3 tells us a rise of 2 and a run of 3, which means up 2 and right 3. We're going to do that from this coordinate point, up 2 and right 3. And then you can draw your line in to connect them. And you'd be finished. Similarly, for this one, we have the same basic information, it's just presented a little bit differently. You should know that y equals mx plus b format gives you a y-intercept, which we can plot on the y-axis at 2, and then a slope, which we know is always a fraction, so in this case 3 or 3 over 1. So that means from here we're going to go up 3 and right 1. We can draw in our graph. And that's done. So these are all lead-in problems to the more complicated ones on systems that we're doing in our last section, 3.1. But again, understanding how to do these and understanding how to do systems are basically the same problem. So this one, we want to have it in the correct format first, which was like the other problem, number 56, y equals mx plus b. So this -3 has to go away. So I'm going to divide it by -3 so that it cancels and leaves just the y. Now the remainder of this is to take -6 divided by -3. Two negatives make a positive, so this is actually 2x. And then 12 divided by -3. Now there's only one negative, so it will be negative. 2x minus 4 is the answer. So we have to graph that. So again, this is our y-intercept right here. So we put that on the y-axis at -4. So 1, 2, 3, 4 right here. And then our slope says 2 over 1 means up 2 and right 1. So right there. We're all done. So again, it's the same approach as this last one, and there are different ways to do this. For example, you can use the intercept method to graph this. But I think in this case, we might as well stick with the same pattern, which is rearranging so that it's in y equals mx plus b format. So that means this -3x has to go away. So I'll add it to both sides. And that leaves you with a positive 5y equals 3x and a -15. So now the last step, of course, is to get this 5 away from the y, so I'll divide by 5 on both sides. And that cancels, leaving y. I get 3 over 5 here, which in most cases would be kind of a pain, but this is actually good because it is a slope and you want a fraction. So here, -15 divided by 5, that is -3. So the equation is now situated the way we want, and it's time to graph it. So the way we graph it is to take this -3 and put it on the y-axis, right here. And then finally, 3 over 5 means rise of 3 and run of 5. Up 3, right, 1, 2, 3, 4, 5. So here. You can connect your line. And you got it. So our last problems are inequalities. Inequalities are essentially the same thing as graphing a regular equation, except they have 2 more steps. So this inequality has a y-intercept of -4, so I'm going to put that on here at -4. And then the slope tells me 3 over 1, so I'm going to go up 3 and right 1. So normally I would just draw in the line and I'd be done with it. Except that in this case, because it's an inequality, I have some more stuff to deal with. first off, the fact that it has an equal to symbol tells me it's going to be a solid line. So I need a solid line here rather than a dashed line if it weren't an equal to kind of problem. And then also greater than tells me that I should shade upward from the line. So what I would do if I were you is I put my pencil, in this case, on the line, and because it's greater than, you want to shade upward, which means this way. So I need shading up in this direction. And now that problem is finished. So similarly, when you have an inequality problem like this, these are going to be on the test by themselves as a single inequality to graph. So you're going to need to know how to do these for sure. Take this one, and again, because I want y to be by itself, I need to divide by -2. And one of those tricks for inequalities that sometimes gets lost in everything is that you have to flip the symbol around when you divide by a negative. So this symbol actually turns to a greater than. And now we have 2 over -2, which is -1, or just -x. And 6 over -2 is -3. So it's ready to be graphed now. So we're going to put that -3 on the y-axis right here. And then this negative in here really means -1 over 1. So I'm going to go down 1 and right 1 here. Our inequality symbol is a regular inequality, not a greater than or equal to. So it needs to be a dashed line instead of a solid line. Meaning that the line is not actually part of the solution, it's just a boundary line. And then finally, greater than again means to go from the line and shade upward. So we'll be shading this way once again. And that's the end of page 7.